Today's lesson will be talking about stoichiometry, or as I like to say, it's a chemist's favorite plants. Ha ha. Anyway, so stoichiometry is talking about a study of quantitative relationships. So the goal of stoichiometry is to be able to convert from amount of one compound to amount of another compound. Yesterday we talked about converting from mole of one substance to another mole. Now we're going to add mass, and we're going to talk about how you can go from mass of one substance to mass of another substance. So, first, once we balance the equation, we want to find out the number of moles of sodium we need to react with 5.43 moles of oxygen. So we start off with 5.43 moles of oxygen, put moles of oxygen on the bottom, and now we want to convert from moles of oxygen to moles of sodium. Moles of sodium go on top. We're going to have 1 mole of oxygen because we've got a 1 here. And we're going to have 4 moles of sodium because we've got 4 over here. Now we're going to multiply on top, multiply 5.43 times 4, and divide by 1, which gives us 21.7 moles of sodium. So that's our final answer, going from moles to moles. But what we want to do now is we want to be able to go from moles to mass. So, to write out this equation, we've got nitrogen and hydrogen. These are both Brinkelhoff elements. So it's going to be N2 plus H2 are going to react to form ammonia, which is NH3. So we've got our equation, now we need to balance it. So we're going to have 3 hydrogens, 2 ammonias, and 1 nitrogen. Now make sure you're writing down this formula. This is what you're going to need to know to go from mass to mass. As we start off with given mass, convert to given moles. Those are the moles that we know. Convert to wanted moles, and then convert to wanted mass. So let's see how this works out in this problem. We start off with 5.90 moles of nitrogen. So these are our given moles. That's what we're given. And we want to find the mass of ammonia. That's our wanted mass. That's what we want to find. So let's start to plug this in. We start off with our given moles. That should be 8.90 moles of nitrogen. We want to convert from moles of nitrogen to moles of ammonia. So we set it up using the ratios. We know that for every 1 mole of nitrogen, there's a 1 here, there's going to be 2 moles of ammonia. So that's our first step, to go from given moles to wanted moles. The next step is to go from wanted moles to wanted mass. So here, we need to go from moles of ammonia to grams of ammonia, going from moles to mass. So this is where we need to use our molar masses. We know that 1 mole of ammonia is going to weigh 17.04 grams. Because if we add up nitrogen and 3 hydrogens, we get a molar mass of 17.04 grams. So, now we've gone from given moles to wanted moles to wanted mass. Now the last step is just to multiply everything on top and divide by everything on the bottom. So that's 8.90 times 2 times 17.04. Which will give us 303 grams of ammonia. So that's the first problem we can solve for the wanted mass, is 303 grams of ammonia. Next up is, so reading this, we say excess carbon, meaning there's enough. Carbon is going to react with 29.4 grams of zinc oxide, and it's going to produce zinc and carbon dioxide. And we want to know how many grams of carbon dioxide gas is this going to produce. So the first step is to balance this equation. So as I'm doing this, work through, you can pause, balance this equation, and then check your work. So to balance this equation, we're going to need 2 zincs, or 2 zinc oxides, and 2 zincs. So now we've got a balanced equation. Now again, we know from given mass to given moles, to wanted moles to wanted mass. So here, we start off with 24.9 grams. That's our given mass. This is what we're given here, that's our given mass. And grams of carbon dioxide is our wanted mass. So we want to be able to convert from grams of zinc oxide to grams of carbon dioxide. And to do this, we first need to convert to moles. So we start off with 24.9 grams of zinc oxide. We want to go from grams to moles. So we want to convert from grams of zinc oxide to moles of zinc oxide. So once again, we're going to use our molar mass. 1 mole of zinc oxide is 81.39 grams. So we've converted from grams to moles. The next step is to go from given moles to wanted moles. To do that, we want to go from moles of zinc, which are given, zinc oxide, we want to go from moles of zinc oxide to moles of carbon dioxide. So going from given moles to wanted moles. And to do this, we use our mole ratios. For every 1 mole of carbon dioxide, we're going to have 2 moles of zinc oxide. So 2 moles of zinc oxide to 1 mole of carbon dioxide. Now we have our wanted moles. Our last step is to find the wanted mass. To do this, we need to convert from moles of carbon dioxide to grams of carbon dioxide. And again, using molar mass. 1 mole of carbon dioxide is equal to 44.01 grams. So now we've gone from wanted moles to wanted mass. Last step is we multiply everything on top, divide by everything on the bottom, and we end up with 6.73 grams of carbon dioxide. So for our last problem, you should be pausing throughout the video. That way you can practice working through this on your own. However, when you want to check your work, just press play, and you can start the video over again. So to start off, we know phosphorus reacts with bromine to give us phosphorus tribromide. So right now, pause the video and write down the formula for this equation. Make sure you're also balancing it to make sure it is a balanced equation. So, coming back, we can check our work and see we end up with 2 phosphorus, 3 bromine. Remember, bromine is one of our Brinkelhoff elements, so it's a diatomic. And 2 moles of phosphorus tribromide. Now the next step is to find out, we start off with 78.2 grams of phosphorus. So, this is our given mass. We're given 78.2 grams of phosphorus. And here, we're looking for moles of bromine. So here, we're just looking for the wanted moles to find out how many moles of bromine this is going to be. So this is only going to be 2 steps, going from given mass to given moles, and given moles to wanted moles. So let's take a look. We start off with 78.2 grams of phosphorus. Convert from grams of phosphorus to moles of phosphorus. 1 mole of phosphorus is going to have a molar mass of 30.97 grams. So here we've gone from given mass to given moles. Next step is to go from given moles to wanted moles. So that means we're going from moles of phosphorus to moles of bromine. For every 2 moles of phosphorus, we're going to have 3 moles of bromine. And now that we have our wanted moles, well, we have what we want, we can just stop here. Multiply everything on top, and divide by everything on the bottom. So that's 78.2 times 1 times 3, divided by 30.97, divided by 2, gives us 3.78 moles of bromine.